The quadratic formula can be used to solve any quadratic equation. We can derive the quadratic formula by completing the square of a general quadratic equation, ax squared plus bx plus c equals 0. Start by removing the coefficient of x squared by dividing every term by a. Then isolate the constant term by moving it to the right side of the equation. Complete the square by adding b over 2a squared to both sides. This turns the left side into a perfect square trinomial, which factors into x plus b over 2a squared. On the right, square b over 2a to get b squared over 4a squared. To combine these fractions, use a common denominator of 4a squared by multiplying the top and bottom of negative c over a by 4a to get 4ac over 4a squared. Combine these into a single fraction, then taking the square root of both sides leaves us with x plus b over 2a on the left. On the right, we can separate the top and bottom of the fraction and simplify square root of 4a squared, which becomes 2a. Move b over 2a to the right, making it negative. Since they have a common denominator, we can combine them into a single fraction. Therefore, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. The quadratic formula can be used to solve any quadratic equation written in ax squared plus bx plus c equals 0, where a is not equal to 0. I memorized the formula using this tune. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Let's try an example. First, identify a, b, and c. Here, a is 2, b is 3, and c is negative 5. Remember to use the signs in front of the numbers. Let's use a quadratic formula. Substituting, we get negative 3 plus or minus the square root. 3 squared minus 4 times 2 times negative 5, all over 2 times 2. Let's simplify using the order of operations. First, evaluate 3 squared, which equals 9. Then multiply negative 4 times 2 times negative 5, which gives us positive 40. On the bottom, 2 times 2 is 4. Let's keep simplifying by adding 9 and 40, giving us 49. Since 49 is a perfect square, we get 7. This gives us two solutions, negative 3 plus 7 divided by 4, or negative 3 minus 7 divided by 4. Simplifying, we get 1 or negative 5 halves. Here's another example. First, write the equation in standard form by moving 4 to the left side and changing its sign to its opposite. Here, a is 1, b is negative 2, and c is negative 4. Substitute these values into the quadratic formula. Negative, negative 2. Notice that we have two negative signs, plus or minus the square root, negative 2 squared, remembering to put negative 2 inside the parentheses, negative 4 times 1 times negative 4, over 2 times 1. A double negative in front of 2 makes it a positive. Squaring negative 2 gives us positive 4. Negative 4 times 1 times negative 4 equals positive 16. Adding 4 and 16 gives 20. On the bottom, 2 times 1 is 2. 20 is not a perfect square, but we can simplify it by taking out a perfect square factor of 4, making it 2 root 5. Since the two terms in the numerator can be divided by 2, we can simplify this to 1 plus or minus the square root of 5.